Today in class 12th, I will tell you about the mathematical analysis of cyclotron. As I have told you about the cyclotron, its construction and the working. The cyclotron is the device to accelerate the heavy positive charge particle like proton, alpha particle, deuteron, lithium ion and sodium ion, etc. So this is the device to accelerate the charge particle, positive charge particle. And now in this mathematical analysis, I have to tell you about the energy gained by the positively charged particle. So now let's V equal to applied voltage across the these. I told you that a radio frequency or the alternating voltage is applied across the dish and the particle gains the energy from this electric field. The energy gained by charged particle is equal to QV. Q the charge on the particle, and we know that in one rotation the charge particle crosses the gap 2 times. It means that in one time this will gain the energy QV and in second time this will gain the energy QV. So total energy will be gained to be 2 QV. So in one cycle the particle gains the energy 2 QV. If suppose the particle makes n rotations, then the energy gained by the particle will be equal to 2 nQV. Let n equal to number of rotations of charged particle. So the energy gained in n rotations, therefore the energy gained in n rotations E equal to 2 nQV. Because in each rotation the particle is filtered 2 times. Because in each rotation the particle is accelerated 2 times. So we have multiplied this by 2 nQV. This is our energy. So much. And at the same time, a magnetic field is applied so that the particle moves in the semicircular path of radius r. the Lorentz force. F equal to Q V B, and the centrifugal force Fc. This is equal to mv square upon r, because this centrifugal force is provided by this Lorentz force. So in equilibrium they must be equal. Therefore, this QVB equal to mv square upon r. So, or this r equal to mv upon qv. This is no radius. It is radius of semicircular path. Inside the D. So now you can have that this radius depends upon the momentum, that is the mv, and that the charge and the magnetic field B. So a very high magnetic field is applied by means of electromagnets, so that this R is to be small. But this value of R increases every time whenever this particle crosses the gap and moves inside the D. So this R becomes maximum when this is equal to the radius of the D's. टाइम पीरियड कितना हो जाएगा इसका? टाइम T equal to pi r upon v. Since the particle moves only in semicircular path, so what we have, that the particle is moving like this in this way. This is now radius r. This is moving with velocity v. This is now velocity v. Then this is now semicircular, so this distance is equal to pi r. So this T is equal to pi upon v into r equal to mv upon qv. This we take now number. This is now number 1. This is now number 2. So this is equal to how much? V and V cancel. So this is your pi m upon qv. This is not T. As the particle completes this semicircular path, the polarity of the D change. It means I have told you earlier that this time must be equal to the half of the time period of the applied electric field. So this is what that we are having it to be like this. This is now 0. This is now voltage V. This is now time t, and this is now your time t by 2, and this is now your time t. This is now your t here. So in this time, this t by 2 must be equal to this value t, so that the polarity changes. When the d which was positive will be negative, and the d which was negative will be positive. In that case, it will happen that this so much time will be equal to the time taken by the charged particle to move in the semicircular path. So what we have? Let t equal to time period of AC voltage, then T upon 2, this is equal to T. So this T upon 2 equal to T, so T is equal to pi m upon QB. So what we are having here? So this T upon 2 is equal to pi m upon QB. So this gives now T equal to 2 pi m upon QB. This is not time period. So how much is the frequency? Frequency n equal to 1 upon T. So this gives n equal to QB upon 2 pi m. Therefore, cyclotron frequency is how much? Cyclotron frequency omega is equal to 2 pi m. The angular frequency omega is called the cyclotron frequency. So this omega equal to 2 pi into n. N is this now so much QB upon 2 pi m. Now 2 pi will cancel. So this omega equal to QB upon n. Now you are looking here that this cyclotron frequency is independent of radius of the circular path and independent of the velocity of the charged particle. The angular frequency omega is independent of velocity of charged particle and radius of circular path. Circular path. So how can we write this one? This omega is independent of V, so this is now your V raised to power 0, and omega is independent of radius R raised to power 0. These are not coming in this factor. So this angular frequency is independent of the velocity and independent of the radius of the circular path. So this is what? That the cyclotron frequency depends only upon the charge with the magnetic field and the mass of the charged particle. The velocity V equal to, this we will gain from here, V equal to R Q V upon M. This velocity is so much, and you can see that when this small r equal to capital R, the radius of the disc, in that case this velocity is maximum. So for maximum velocity, for B maximum, R equal to capital R, the radius of D's. Radius of D's. Then B maximum equal to R Q B upon M. Now this factor, in this small r, that will be equal to capital R. When this velocity is maximum, then kinetic energy will be maximum. So maximum energy gained by the charged particle gained by charged particle E maximum equal to half m B maximum square. So this is equal to half m and B maximum is equal to R Q B upon m. This is now whole square. So this is equal to R square Q square B square upon 2m. This is equal to now E maximum. So much energy. It means what? That for maximum energy, to increase the energy of the charged particle, D's must be of very large radius. Of very large radius. So R must be large. Q must be as much possible as. So this is a very high positive charge particle. B, the magnetic field. Very strong magnetic field should be applied perpendicular to the plane of the D's, so that this is maximum. This is what that it makes the machine to be a very large one. So for increasing this energy, the energy, or you can say that the energy, maximum energy depends upon the radius of the D's, charge the Q, B the magnetic field. But now what about M? This M must be heavy one. M must be large one. So that this maximum should be small one. If M is to be very small, then what will happen? When the particle will be accelerated to be very high energy, this mass will change according to Einstein theory of relativity. Thus, energy acquired by particle depends upon the radius of D's, the magnitude of charge, and applied magnetic field, the mass and mass of the particle. Mass of the particle. So these are the factors upon which the energy of the particle depends. Now, as I told you that when the particle acquires a very high energy, the mass of the particle changes according to Einstein's theory of relativity. It means that the very light particle cannot be accelerated by means of this cyclotron. So, limitations of cyclotron. Limitations. The electron cannot be accelerated by cyclotron because it being a lightest particle, its mass increases with increase in velocity according to Einstein theory of relativity. So what we have? M equal to m0 upon square root of 1 minus b square upon c square. So you can see that as this v approaches to this c, then this m will increase, where c equal to velocity of light. So it being a very light particle, the mass of the particle increases very rapidly as the velocity approaches to the velocity of light. So because of this one, this cyclotron cannot accelerate the negatively charged particles. So this is what the analysis and the limitation. And now I will tell you the uses of cyclotron. Because the particle is accelerated, so the artificial radioactivity and transmutation can be done with the help of this cyclotron. Now, uses. Number one, it can be used in artificial radioactivity. Number two, It is used for transmutation of elements. Transmutation of elements. Used to make isotopes. So also it causes the nuclear fission. It may cause so this is what the uses of the cyclotron. So this is about the cyclotron, and from this a question of 1 mark or half mark or 1.5 mark is asked in the board exam. So you all study it carefully. Also sometimes the question is asked in the some competitive exams also about its name of the inventor, and that the particle, which kind of particle can be accelerated by this one, this is also may be asked, and the maximum energy gained by the charged particle, and the which particle cannot be accelerated by this machine, that is the electron. So thank you very much.